Wait, Richie, whoever has to affect time, whoever has to. Yeah, it's for. I need to change. Trying my best, bro. Giving me trouble. I'll let you know. Thank you.
Hello.
The presentation of the 2025 UQCS Hackathon.
Okay.
Next, we have Craig, who's a Microsoft manager at Amazon. Craig, you can just raise your hand at the audience. This is Craig, he's a manager at Amazon. Next, we have a child prodigy. His name is Matt Chen. He's a graduate working at IMC as a software developer. He previously studied at UQ and he graduated last year. Yes. Big shout out to Matt. Lastly, we have Alistair, who's a software manager at Oracle. Alistair, can you just raise your hand? So the presentation will consist of 6 teams. So those are 6 teams that's choosing that the top 6 votes during the voting phase. And out of the 6, our beloved judges will choose the best overall prize. That team will be eligible for $2,000. And next, they will choose the best overall runner prize, and that team will be eligible for $1,000. Over how the prizes work. The best always must on the first year of the test. And next, so people choose the competitive project. And next, we have inter project. Project knowledge from. Next is our best game. And next, best presentation given okay project the best. And we have the most method. So this project is team of which project that you have to, but it just asks why did you. And next last week, everyone is given can bring working of $0 and valuable to. So with nothing much to say, may the best team win. So first team, can I have proof by Minecraft? Can you guys come to the stage and present your project?
Need a mic.
Oh, yes.
I just need a mic. I'll keep time. No, what about them? Don't worry.
Oh, no, yeah, they can use that. No, they can use that. They do? No, they can use this.
No, they can. If they
Yeah,
want.
if that works, okay.
It's a lapel.
Yeah.
Yes. Are you a lapel? Yes. Okay. Do you know how to cook it all?
Yes.
Just one for me, please.
Okay. What about the joint?
If you don't. Oh, and just do a little test on the mic. Are you happy with that? Yeah, that's fine. Perfect. If you want to pass it along to him, you can also just. You have to hold. This is for the stream.
You can also clip this on your thing, but
Yeah.
if you pass it mine, you'll pass it.
I'll just hold that. So what do?
Are we able to connect off the laptop?
Yeah.
You guys have present it, stay within the light. We can see you in the light.
Okay, can we put a laptop? Connect the laptop?
Just a friendly reminder that the
Can we
presentation
connect it?
is 4 minutes.
Yes, you.
And we have 3 minutes for the judges. And our lovely sponsor officer will cook once if there's only 1 minute remaining, and she will cook twice when we need to wrap up.
Richard, swap laptops.
Yes, we can do that.
This is introducing Minecraft. It's a brilliant logic simulator within Minecraft. It's mostly comprised of 3 stages, which I'll briefly introduce: parsing, leveling, generation. But for now, we'll keep that on hold. I'm going to give John the ability to do a demonstration, but he'll talk about his motivation, and I'll touch back in with you guys at the end for application. Yeah?
Yep.
Come on. Okay.
And we need to give it some small little nudge with audio as well. When it's Q&A time, just keep going back and forth, like passing the mic to the judges.
Absolutely.
Right? So like when they have questions, go to them. They'll speak into that little microphone for the live stream, and then they give it back to you, and you speak into it.
Okay, when do we start?
I'll let you know.
Okay, absolutely. Can we get our laptop set up, please?
So if you just go out, if you have listened,
Yes. No, I'm not sorry. Good.
Boolean algebra logic simulator.
And you want me to talk about the inspiration?
Yeah, yeah.
Okay, and I'll pass you
Back for applications. Yes. So talk about your motivation, intuition, applications, and do your thing, right?
Okay. Oh, this is.
Within the line.
Should I open it up and give a quick demonstration?
Yeah, I thought we were doing that.
Okay. Alright, let's start.
All right. Hello, everybody. My name is Matthew. This is Pajon. This is Josiah. This is, how do you pronounce it? It's Wei. And this is Gus. We are Proof by Minecraft. So tonight we will be presenting our project. Proof by Minecraft is a Boolean algebra logic simulator within Minecraft. It utilizes it as a lovely tool. It's mostly comprised of 3 stages, our program. That'll be parsing, leveling, and generation. But for now, I will let Pajon do a brief demonstration and talk a little bit about his motivations behind the project. And then I'll touch back in later to talk about some applications, more so personally for me.
Yes, all right, thank you very much. Here we go. Yeah, so many of us, of course, have worked with Boolean algebra, whether it's like in 1061 or wherever else it may have come up. But like it's quite interesting because firstly, it gives you a way to like describe with an algebraic system like the connections of like a physical circuit, whether it be a set of logic gates or whatever it may be. Now, sorry. While we can understand the algebraic manipulations quite like with a bit of practice, it's always fun to get your hands like a bit dirty and actually start to see why like what you're doing works and how it all works. Because when you're first learning logic gates, you might be thinking, okay, well, I see what to do, but I don't understand why I do it. So some of you may have seen I'll just give a quick recap, by the way. Our example we've given here where you can create a truth table using our program. So over here, you input your expression in Boolean algebra, and it will give you like this command, which you can then use to construct this in the game with just one simple easy step. Now, sorry, so in this case, you've just got, you know, like, this is, sorry, it's a bit hard with just one hand here, but you've got, yes, thank you. So yes, I'll make this a bit larger. So over here, we've got our input, like input A and input B, and we've got, well, because you've got two variables, you've got 2 to the n possible input combinations. So we've created like essentially a truth table in the game, and you can see it's represented by firstly you've got 0, 0, and then 0, 1, 1, 0, and 1, 1, and the output values for each of those cases. So 1, 1, 1, and 0, and that gives you a truth table. And I'll just quickly gloss over this, but by De Morgan's law, which many of you have probably worked with before, we've got what should be an equivalent expression, so not A or not B, which should be equivalent to, sorry, not A and B. And as we can see, for the equivalent input values, we've got the exact same output set, so 1, 1, 1, and 0. So essentially, my inspiration behind this was just, I thought it would be quite fun to see if we could actually really translate these logical operations into real, like, well, into logical gates in Minecraft to see exactly what's doing what. And now, like, for example, you're able to go play around with things, see why it's doing it and how it's all working. And Matt has a bit of an inspiration behind, like, on the educational side as well as to why we may do this.
In terms of applications, I am a tutor. I tutor year 11 and 12, a variety of ATAR subjects. And in the year 11 and 12 syllabus for engineering, logic gates is actually something which the students are required to cover. Unfortunately for these students, they seem to find logic gates quite unintuitive. I get a lot of complaints. They don't really relate to the content in a lot of different ways. Unfortunately, with like discrete maths and especially its applications, they can feel very abstract, especially when you're in year 11 and year 12. I even took a gap year and I did 1081, and logic felt very abstract to me, despite it making sense. It's logical by definition. So to provide these students with something that they can interact with tangibly makes a world of difference to break that barrier between abstract and practicality. So if we keep moving in this direction, this is really just a simple prototype. It could be expanded to things like computing. This could work for university students or children even younger. We've seen like the advent of things like Scratch, which are so popular and so effective at teaching different people different things and breaking down accessibility barriers, right? Logic gates, they're very complicated to look at. You're using your brain. It's so abstract and intangible, but you've got something to play with, levers to mess around with. Thank you. I think it must be time.
Oh, sorry. Let's just keep this on you. You're going to be answering some questions. Yep. Yeah. Over to your judges.
Thank you. Anyone? Either of you have a question? I don't think I need. I have to hear. Okay. Thank you for that presentation. How portable is this to other games? Is my question. Like Roblox or maybe Tears of the Kingdom.
What was that question, sorry?
How portable is your system to other types of games, like perhaps like Roblox? Like there's.
This one's probably a bit of a tricky one for the answer because I've not really worked at like implementing subsystems in other games, but given that like all the hard work has already been done in translating your logic gates into like essentially a graph, like a tree, and all the work for positioning all these nodes so that you have a logical physical layout has already been done. says that each, like, if we were to want to, or if we were to implement it in Roblox, sorry, all we need is the capability to place items in the world which represent logic gates, and also we would need the ability to connect between these gates. As you can see here, the layouts have all been calculated, and the connections have all been calculated in their exact positions. So we would just require an equivalent system of gates.
Okay, thank you.
Great job, guys. Hope for the last few days have been not as tiring as it looks. So my question is, where to from here? What are you going to do with this? What's next?
That's an excellent question. So I'm sure some of you may have seen, like, on YouTube over the past number of years, a lot of people make very complicated, massive computers in Minecraft. Now, these are very simple logic gates, but they do form the fundamental building blocks for such computers, whether it's like memory registers, whatever it may be. I would like to be able to maybe add subsystems such as memory modules that make use of some of the gates we've already got, maybe a clock system to perhaps start to explore the computing side of things. Because the ability to make, like, to expand this to the computing side, like, well, like, to make more so a computer, but in a simpler form, would potentially help with people understanding, like, the different aspects of the computer and how they relate, like such, like whether it's memory, clock, and other aspects such as that.
Cool.
Good. Great job, guys. I think that's a really impressive project. The example that you showed up there, you know, it's a fairly small Boolean expression. I was just wondering if you'd done any experimentation with, you know, much more complex Boolean expressions that had a lot more components included in them. And, you know, are there any sort of limitations inherent in Minecraft itself which would sort of limit what you could actually do there?
One of them is that the max characters for input into command block is about 32,000, right? So if you expand it to too many variables, or if it's too complicated, you can get stuck on that. I think there might be a way to expand the amount of characters that you get in one command block, or we can split into two like commands. Like, it's not too big of a block, I think. In Discord, I sent our math 1081 equation.
Risky move.
Just copy that. Put it in. So this is from our advanced discrete math assignment 1 paper, right? Table. You don't want to do table. That's one limitation. Like this one.
Yes.
With you.
Sorry, guys. After this. So thank you, Team Minecraft. I wish you made this project 5 years ago when I was doing CSSE 2010. So can I have the next team to present Easy PCB?
I'm gonna tell them to do something with this mic.
Okay.
Oh my god. Are you both speaking?
Yeah, we'll swap in the middle.
Okay.
It's all right.
All good. Oh, you're just up there? Okay, perfect. Let me. One. Test the mic out for yourselves. Let's see.
Can everyone hear us?
for the stream, when you're presenting, just use this as well. When it comes to Q&A, if you could pass this back to the judges as well and just take it back when you're answering. Sure. Yeah.
Good evening, everyone. I'm Mac, this is Zach, and this is Easy PCB. PCB is a printed circuit board, and it is the backbone of our modern world. In this room we stand in right now, there are hundreds of PCBs, all painstakingly laid out by poor, hard-working engineers like yourselves. Zach and I have set out on a mission to change that. We've built what we believe is a fairly novel auto router and auto placer for creating PCBs directly from the schematic. So, the way it works, you have your choice of PCB design software. Altium at UQ, we used Easy EDA for this. You export a file, our program runs on that file, it produces an output file, and you import that back into your choice of CAD software. From there, you can export it, send it to China to be manufactured, and it'll arrive within days. Next slide. Auto routing exists. It's been done. It's generally very bad, and it strives to complete the circuit just where the components have originally been placed. We are taking a radically different approach. We give a few abstract sliders. So as you'll see, we've got board size, component spacing, via count, and route clearance. And so you set those, and we will design the PCB according to your exact specification.
So this is pretty much what the software will spit out once you've converted it from a schematic into a basic PCB. Now, nothing here is arranged. The red is where copper will be, and the blue is where things need to be connected together. Now, as a human, normally what you have to do is arrange them in some logical way and then effectively connect the dots. Now, this is a painstaking process, as Max said. It can take days or weeks for complicated designs to be routed, and you can imagine for a large PCB, that's a very expensive process. So what we do is we run some optimization on the position. First, we try to rotate each component to make sure that, or try to minimize the number of path crossings. We then apply a force to each component along a net to try to group them together to reduce the trace length. Once that happens, we're in a position where we can route all the copper traces together. And this is done with a slightly more complicated A-star based maze-solving algorithm. At that point, we can get a finished PCB. So I guess, like, how much faster is something like this? And how much time does this actually save? I raced the PCB auto router that we made. It took me about 45 minutes to route a board just like this. It took our solution only 2 seconds. So this can clearly save a lot of time, and it's a very useful thing. It's something that Mac and I, as engineers, would use all the time, and we really look forward to developing it more in the future. Thank you.
Again, another excellent project. So you mentioned a large board. So how have you tried it on a much larger board, and how much faster is it?
Yeah, so at the moment, this is kind of at the limit of the complexity of what we can do. Of course, we haven't had much time to do it, and it's definitely very scalable. In terms of like how long it would take, we're not entirely sure what the time complexity of it is, but on a larger board, we tested one with about 100 nets, which is about like 10 times more complicated than this one, and it would have taken about 5 minutes to run on my laptop. So it does get slower, of course, but yeah, again, it does save a ridiculous amount of time. Oh yeah, a lot faster.
what scenarios will your algorithm struggle with? Like if I give a really tiny board where all the pieces can't fit, will it still work?
Yeah, sure. So we haven't just killed every PCB design engineer. It's not perfect. Like if you told it, I want to minimize board size, but I also need to maximize the spacing between my components, it might not be possible. So there's situations where you physically can't solve the problem, and it'll tell you, oh, we can't solve this, adjust this parameter, perhaps. The rotation that I've implemented at the moment for finding the optimal orientation of components, that probably works up until a limit of about 16 components before the time complexity just gets too much. So it's a pretty crude algorithm, could definitely improve that, but I'd say that's probably the bottleneck of it right now.
Are there any like big plans to expand this? For instance, give more sliders and more customization, maybe?
I really want to, yes. This is, as I say, something that I absolutely would use, and I'm sure a lot of engineers would like love to see something like this, which is good. It's shocking that it doesn't already exist, but yeah, just probably more complex algorithms that are able to handle edge cases better is going to be the big thing, and just making it more reliable, getting reliability up first, and then improving time cost.
Yeah, we'd love to see it actually exist in the world.
Great job, guys. This is really impressive. Just a question from me, I suppose. The input schematic that feeds into all of this, is the way that is laid out, does that impact anything at all? I'm assuming probably not, but you know, does the arrangement of the schematic affect the outputs at all, or the performance?
Surprisingly, not really. It turns out it's all remarkably standardized between PCB softwares. We're using a file type that was from like the late 90s, and it hasn't changed at all. It's as basic as it gets. It's just information about the geometry of the pad and the network of how all the pads connect together. So it's very generic, and we were pretty fortunate that the old technology still works well, as it turns out.
Yeah, and then because of course we do auto placement, then it's really up to us. So no matter how the components actually arrive, whether it's in a line or like in the shape of a bin chicken, like it doesn't matter. We handle it all on our end and then pass it back in a readable format. Awesome. Thank you.
Thank you to Team PCB. Again, I wish I had your program when I did Study 100. It would have saved me thousands of hours and would have bumped my project from a 7 Pro to 8. Yeah, I think that was definitely possible. So next, can we have team? I trapped AI in a calculator.
Hello. Set up. Which mic would you like to use? Would you like to use this mic, or would you like to use a cable?
I don't mind.
Are you going to stay here?
I'll stay here.
Okay, cool. We can just use the lectern mic then. As for the stream, so make sure firstly that you're talking into that mic, but also this is our stream mic, so just talk into it. When it comes to this question time, just hand it back and forth between yourselves.
Okay. I trapped an AI in a calculator, and it only took me about 48 hours. So I've worked with Desmos graphing calculator a bit before. I've made a RISC-V emulator in Desmos, so a general purpose computer, essentially. And I was inspired to choose this when I saw, like the Minecraft team said, a YouTuber made a computer in Minecraft Redstone. And they actually trained an actual model very similar to what I did. So it's an image, it's a handwritten digit recognition model. So I think I can actually... And hopefully it doesn't mess up. That's a 3. So it's a neural network with a convolutional layer first. It's a 5 by 5 by 4 kernel, which means it essentially outputs 4 images. It then goes through max pooling to condense the size of it down into quite a small image that gets fed to the 3 dense layers, which then outputs, and to a softmax layer, which outputs its prediction of the number. It's trained on the MNIST handwritten digits dataset, and it got about 96% when I trained it in Python, but only about 80% here due to the way that people have to draw with a trackpad. So yeah, I trained it in Python, which you think would make it easier, but it means I need to basically do the model twice and make sure it matches exactly so that all the weights will correspond to the right image. That was really where I messed up the most, is getting it to match. That's about it. I can keep drawing numbers all you like. It failed on 6 most of all. I don't know why. I suppose it looks similar to a 5 and an 8 and a 0 maybe. But also, most people this afternoon drew a 6. So if you were one of them, shout out to you, who probably saw it not work.
Really interesting projects. I would say that. I also drew 6 when I came 5 correctly. Just interested in the data that you mentioned. I think it was the handwritten data library or something like that. Is that a standard one used sort of thing, recognized for use, or could other ones potentially?
Yeah, so it is a pretty standard data set. It's 60,000 images of digits 0 through 9, and the images are 28 by 28, and it also comes with 10,000 testing data images. And that's pretty standard. You'll see that everywhere. Of course, actual written recognition models will use much better data sets, but this is basically the 101 of image recognition machine learning.
I'm really unfamiliar with coding in Desmos, so how exactly did you do all this? Because this all looks like magic. Yeah.
So yeah, it's all done with functions and lists. So for instance, and the lines are long. So for instance, here you can see functions to get a cell, get a row, get a kernel, do a full convolution with a given kernel. Lots. This is pooling. This looks complex. It's basically getting an image and finding the max of 4 pixels, but it has to do that for every 4 pixels. I've loaded all the weights in. I had to copy paste them. This one's only 100, but that's not a lot. In this folder here, if I open that, it might crash my browser, because it's got about 3,000. Yeah, so lots of functions, lots of lists, and it's quite slow.
I know probably all of this was very difficult, but what would you qualify as the most difficult thing you hacked into the Desmos system? Yeah.
Well, Desmos, it's a graphing calculator. It's made for graphing things. It does not have matrices and matrix operations and multiplications, so I had to implement that all myself, essentially. The matrices, it's pretty, matrix multiplication, everyone can do it. It's summing up over the rows and columns. So that was achievable, but like I said, making sure this matches the model was the hardest part, because Desmos, it only has one-dimensional lists. So I had to figure out the direction of the lists. That was the main issue.
Yeah, wow. So are you going to send off a whole bunch of improvement requests to Desmos and the calculator company to help you do this thing a whole lot better?
Well, since when I first started using Desmos a few years ago, they have brought out a lot of improvements. Like, it didn't have recursion, and now it only has simple recursion. The recursion system that they have now still fails most of the time, and it fails in weird ways that doesn't give you any indication of the error. And they only recently added complex numbers. So now you can have complex numbers. There's loads of limitations still. Recursion is obviously the biggest one that you want in a programming language, but also lists can only be maximum of 10,000 items in length, which sounds like a lot. That's only like 100 by 100 in length.
So now re-implement it all in forward.
No. Thank you.
Thank you for the presentation. I wish you were my ML lecturer for all my ML courses. I would have learned a lot more from you, no doubt. Yep, so next, could we have Mr. Reliable to present?
Would you like to use either Excel or the mic here?
I can use mine.
Just test how you feel with it.
Hello. Yes.
Okay. So we have this mic for streaming. Now just use it like when you're talking, and when the judges do Q&A, you'll just have to be the mediator to move it over.
Okay, absolutely.
Thank you. Right here.
How close does it have to be?
Pardon?
How close does it have to be?
Oh, just like even this far from you. It's fine.
Thank you. Hello, everybody. I am Ryan Hurst, also known as Mr. Reliable by very, very few. Today, I'll be talking about my Godot game, To Kill a Labubu. But first, I should probably recap what a Labubu is and what started this whole mess. So I'll first explain a performative male. They're essentially a guy who dresses for the female gaze in a way where they're wearing labubus like this and they're drinking matcha latte and they're reading feminist literature just to get the a female gaze. A labubu, this is Gregory.
I'd like to thank Zane for giving me this gift. It kind of started everything. And I also feel this brain rot, some people might not get it, but a lot of people do. And I feel it helps kind of build like a community. I had a lot of people come around who are like, oh my God, you got this, you got that, like reference and all that. And I feel like that helps build like a community, which is really cool. Godot is a open source game engine. It's programmed with GDScript, and it's kind of like an up and coming game engine ever since Unity and all that started like price hiking. I will give you a demo of my game. Yep, this is, I'll turn it down a little bit. I don't know how to fix this. I'm currently here.
Oh, this is a map.
Yeah.
Sorry, this is a map. I don't know if you're on a map.
Oh wait, does this work?
Oh yeah. Okay.
Okay, sorry. Okay, yeah, I'll start. So it is essentially inspired by a game called Call of Duty Zombies, where I, the Labubu, have to defeat, books like 48 Laws of Power. These are doors. Here's some like jorts and all that. That's what some guys do. So I can come down. I created these in like pixel art myself. I'm not really a pixel artist, but I'm trying to get into it. I come down. I can also grab this other one. And the whole point of the game is to come to this matcha latte and unlock it. So it's full of all these like Gen Z, pop references. And by special request, we have Drake. I'm here. So a really important part of this was this time thingy that I implemented 5 minutes before the due line. You can see I completed in 50 seconds. If I come back to this. Yeah, so a speedrunning community. So I very quickly had a lot of people come, and some, went pretty quickly, but some also came back to try speedrun my game. So I'd like to give a big shout out to Kit Kat down there, who got the best time of 9.7 seconds. I think it's also important to, as a developer, to listen to the people who play your games, because they're the ones who are kind of like your stakeholders. I put some glitches in to make it easy to speedrun. So I had like a reload glitch. These things can just they're little bugs, but if you don't fix them and they're not harmful, they can really help make the game a bit more interesting and allow you to, speedrun. I put Drake in by special request. So always listening. For me, I slept 2 hours last night. I just spent the past whole day working on this and a half straight. It's really rewarding to see people come in and try to beat my game as quick as they can, and just have this little community of people. I'm not really interested in this that much, but yeah. Bless, any questions?
I don't really have a question. I just want to say I appreciate that you finally gave me a way where I can defeat Drake. So thank you for that. Right.
I'm not sure what my question is either. What truly inspired you on this one?
So a few months, I've always been interested in video games when I was younger, and I was always interested in trying to maybe develop my own video games one day. And that's turned into a bit more of a, I want to kind of get into the more physics engines part of the games, because I think that's just more interesting. But this is a good starter. So that's kind of the inspiration. Like I said, I got gifted this, and it kind of started the whole thing yesterday, which was pretty extraordinary. But yeah, I like creating things. I like seeing like communities of people try to use my thing and try, beat it or play around with it and make like, poke fun at it, whatever it is. But I just really enjoy that sense of community.
Yeah, I don't have many questions, but now that you're got a Labubu and a performative male game, would you consider yourself like a performative male?
That's a very good question. No. I refuse to buy a pair of jorts, despite being requested to buy them many times. March is a little bit overrated in my opinion, but the Labubu is really, really cute. I'm kind of attached to Gregory now, so that's really cool.
Thanks, that's impressive. I think I struggle for a question as well, to be honest. Just stunned admiration in that effort. That's fantastic. Any plans to develop this further, or do anything else?
Yeah, so microtransaction. I'm just joking. I'm just kidding. Yeah, I'd love to code more of these games, particularly make them a bit more complicated, a bit less memey, a bit more serious, but like also have hints of like fun and all that in them as well. But I'd love to, over the summer, maybe when I'm a bit less busy, try to code out a bigger one, like a fully running game. And also get into like a few things I'm not really that interested in, like art. I'm not really an artsy person, but to make these cute little games, it requires you to make a little bit of art and to kind of branch out into things that I'm not comfortable with, but I'm definitely willing to learn. That one?
Thank you for your formal definition of a progressive male. Sorry, performative male. Now thinking about it, I do know some people that fit under that category. Well, on committee as well, but anyways. So next, can we have Brain Bites to the stage?
Hello. You can walk around with this one. So, are you all going to be talking? Yeah. Okay. So, I would hold this. This is the actual microphone. And then the other thing is that you're going to have to use this as well for the stream. Okay. So it's going to be a bit of a juggle. So we'll just like hold it up. Yeah, you could probably do something like, hopefully. Let's see. Okay. My bad. Okay, just hold it like this actually. And then you should be good. And then when it's question and answer time, just pass it to the Jessica. Cool, thank you. Cut it up.
All right, hello everyone. So today we're here because we have a problem. See, my name is Sarah, this is Daniel, and that's Nikita. And as you can see, we and most people in this audience and a lot of people in our generation have a problem with spending more time on Reels than on our course content. So we have come up with a solution called Brain Bites. We turn your course content into brain rot Reels. So instead of scrolling Reels and wasting your time, you can actually learn while you're scrolling.
So I'll give a quick rundown of how it works. So we've got an LLM that has access to some Blackboard scraping tools via MCP, which is Model Context Protocol. Then the LLM will recursively check through your Blackboard content and see what courses you're doing, what content's being covered week by week. And it'll look through the courses and also download the PDFs for the lectures in order to find which topics are relevant to you, and that should be converted into scripts for the next part of the code to use.
Yeah, so because it's using model context protocol, the scripts it makes are factually grounded in your course material. So it shouldn't make mistakes, but we've got to be wary with AI. Okay, video generation. How do we actually make the brain rot? We cloned Zane's voice if he's in here. So you can get Zane to teach you stuff, and that's using 11 labs. It synchronizes with captions to keep engagement, which is so vital for students. And then we also, we just composite it together, and it's fantastic.
There are 4 Sigma principles that are straight 5. Encapsulation, inheritance, polymorphism, and...
All right, so how it... Maybe I should have gotten a brain rot thing to explain this instead. Cloud infrastructure. So basically, the scraping that happens on the laptop at the moment, so how do we actually get it to a phone so you can scroll it not while crossing the road? You use, so we use an AWS S3 bucket, so it's cheap, it's fast, it's reliable, and then we put it into a mobile app with a TikTok-style interface so you can scroll. If you understand it, you can click like. If you don't understand it, you can click the confused button, and then it will resuggest it to you so that you build that reinforcement and make learning connections so you can get 7s.
You guys are probably paying attention a bit too long, so we've got a bit of a
Robot
break.
walks into a coding bootcamp and gets immediately overwhelmed. Bad joke aside, generative AI is reshaping how we approach programming. Studies show it's a double-edged sword, potentially boosting efficiency while introducing subtle productivity traps. The real challenge? Moving from doing to supervising. When AI generates code, your job becomes less about typing and more about critically assessing every generated line. Research suggests over 50% of AI-generated code can contain subtle errors. So while these tools can make easy tasks easier, they can make challenging problems near impossible. The future of programming isn't about replacing human creativity, but augmenting it intelligently. Choose your AI assistant wisely.
So that was a reel generated from my Mech 2700 course, and what it's done, it's picked up on the part of the course where they're talking about use of AI and how you can use it to assist you in the course. And so then the AI has read that content and produced that content related to the course. And so for future scaling, we would like to change the screens, like the scraping of the Blackboard content to use the official API for Blackboard. And that would reduce the internet traffic going to and from the program in Blackboard, and it'd also be a lot faster. That's it. Oh.
Oh, it's a magnetic.
No.
Oh.
I'll just get a little thing. And now it's stuck.
Well done, guys. I really like this project, actually, when I saw it earlier on. Just wondering, when you're extracting content from the material you download off Blackboard, roughly how many videos would you get generated from, let's say, a week's worth of slide decks? And second question is, how well do you think your system is surfacing the really relevant content from that?
So as for the how many scripts gets generated from a certain amount of content, that's kind of configurable right now. So in the extraction tool, you tell the AI to target a certain number of scripts to generate, and it should just keep searching until it thinks it's got enough content for the scripts. So, but usually if it picks up a lecture, it will make a one reel about the lecture. If it's about a lecture about and and OR gates, it's gonna make one reel explaining and and OR gates. And then what was the other question?
How accurate?
Oh yeah, how accurate. We found it's pretty accurate to the lecture content. Also, I did a lot of testing on my courses, which are more introductory, and since it's introductory content, the AI in its training would have seen a lot of that sort of content, explaining differential equations. So those explanations seem to be pretty alright. So we haven't tested on more complicated topics yet, but we also, since we've implemented MCP, switching out the large language model is really easy and quick. And so as progresses in that field happen, we can keep switching out and keep with the latest technology.
Yeah, that was a pretty cool project, I think. Yeah, so since you guys are using a large language model backend, how do you guys know any estimates on how cost effective it is to like generate a reel or like 100 reels, for instance?
Yeah, so throughout.
Are you good? You good with the costs?
Yeah. So throughout the testing of the weekend, we've like produced like probably close to 100 reels. And so for the large language model, we've like only gone through like just over $2 of credits for that. And then also for the 11 labs, which is the voice generation, we've only gone through also, like we've put in like what, $10, $15 into that. And we've only,
No, we've barely scratched it.
yeah, and we've barely scratched into that one. So we haven't like used much on that end. And also the AWS bucket is not using very much at all because,
2 cents per 100 gigabytes.
yeah,
Well,
2
it's
cents.
2 cents per 1 gigabyte, so 100 videos for 2 cents.
Yeah, 100 videos for 2 cents. So all the costs are pretty low. One caveat to that though is if you do, right now we're using Claude 3.5, which is one of Anthropic's like much smaller models. If you switch it out for like one of their like larger state-of-the-art models, the cost will balloon pretty quickly.
Yeah, my question is also about the voice generation. Is it attractive and is it sort of technically feasible to try to get these reels to generate using the voice of the lecturer?
Yeah, well, so Zane's voice already was cloned. So if you guys have spoken to him, you'll see that it's quite uncanny. And yeah, it just requires, with the lecturer's consent, to have a few minutes of them speaking, which, must be really hard to get from a lecturer, right? Yeah, that was from, Zane's voice was from 3 minutes. It could probably work with less, but just like more is better. And yeah, obviously just with the lecturer's consent, it would be possible.
So arbitrary audio is something that has to be read.
Oh, that was arbitrary audio.
So yes, very
So did I hear that right? One reel, one lecture, so that you can compress an hour of Paul's work into one reel. Seriously, good job. Where are you going to take this one?
Well, since we've gotten a lot of, actually, yeah, this is your expertise.
Okay. So currently we're using one S3 bucket that's actually kind of public at the moment, but we're going to work on that. So if we want to scale it, and I think so many people want this, I'm going to use it. Because we built it on top of Amazon Web Services, we can implement like their CloudFront stuff to develop a more comprehensive content delivery network. And then also that web scraping stuff, even if we never get the API for it, we can put it into an EC2 instance and run it on a server, so it can be fully mobile and you just log in and it's more seamless, but then costs go up. So that's something costs. So maybe there's a freemium model and we make money. Yeah.
What was that team? Brain Bites.
Thank you, Brain Bites. With your app, I'm sure I can start passing my courses. Yeah. So we saved the best for last. Not quite, but anyway, lucky last. Permanently insane.
Hi guys. Would you like to use this mic or a lapel? Lapel you can walk around with. Yeah. Yeah, sure. Okay. So actually just this is like if you're gonna pass it on to each other, just hold it. Something like this, right? You're gonna also have to hold this string mic, sorry. So someone else could probably hold it. Just speak into it like this. When it's question and answer time, just pass it to each other. So take it back.
Yeah. Do you want to get that set up? Huh? Plug it in? Yeah.
Yeah, just don't forget to pass the mic.
Yeah. We just hold both of these.
Yeah, exactly.
How do I plug in? HDMI, right? Or the USB-C? Oh, okay. Yep. Unified just means it'll be the same thing. I think it's just duplicate. Right, so there we go. Alright, it's on. Showing the frame, like your face is to glow, just stay within the light. Because like the camera picks you up really well if you stay. Okay. Got one for now. Alright, start. Yeah. You guys want ready? So out. Is it connected? Hello? Hello? Okay. Alright.
Well, all right, so our team is terminally insane because we went kind of insane doing this. We have created a Raycaster, which is a pseudo 3D engine that runs within a terminal. So right here you can see a server is being created. It's also multiplayer, by the way. A server is being created, and he is now connecting to the server on his own device.
It's not the right thing.
It's not the right thing, you're right.
I guess this is sort of a program for like all of your Vim users that just want to stay in the terminal, and you want to play a game but you don't feel like exiting the terminal and opening it up, then this is exactly what you need. And in theory, if it does boot up, which would be very nice, it's so it runs directly from the terminal. Don't have to leave. You don't even need any sort of like applications installed in the first place. All right, so there it is. It looks pretty cool. I guess one of the nice features, it's also dynamic, so we can zoom out. You could demonstrate, you could zoom out a bit, and it'll adjust the detail as you go out. So obviously, the further you zoom out, it might start to get a bit flickery. It looks pretty smooth right now. It's all in C, relatively fast, using end cursors to render onto the terminal. And did you want to? Okay, I'll let them. I guess maybe the main features that I was working on was getting the sprite textures to load. So I sort of designed those wall textures there, and you have to then actually put those onto the walls and scale them so that it matches nicely. As you get closer to the wall, they scale up to ensure that it covers the whole region. I believe they're trying to get the multiplayer to work here. Is that what you're trying to do? Oh, you need the dongle.
Yeah,
okay, well maybe I don't think we can demonstrate the multiplayer, unfortunately. Then
I can get my bag if we have time.
I'm not sure. Yeah, there's not time to demonstrate the multiplayer, unfortunately. It does work. You can take my word for it, or you can not believe me. I don't know. I guess, did you want to demonstrate? Get up closer to the walls. We can see a bit of the. Yeah, you can see the sprite texturing there. Can you see the guns as well on the?
There's a shotgun somewhere.
You should be able to pick up a shotgun over there. So yeah, we've got a few textures like that. It's not a complete game yet. Like there's still work that needs to be done, but I think the proof of concept's all there, and the whole design's there. Maybe, I don't know, should we try to push the limits of it, see how far out we can zoom? Yeah, see if we can zoom out further. So you can see, obviously, now we're really zoomed out, so there's a bit of flicker to it, but it essentially resembles a actual Wolfenstein-style game like this, just if you ignore a bit of the flickering. All right, I think that was pretty much all I wanted to demonstrate. Okay, we might be able to get the multiplayer working. We got another. Okay, if you guys want to wait around for like 40 seconds. I'm pretty sure my friend's Wi-Fi card doesn't work, so he needs an external dongle, but there we go. All right, we got it working. He's called Terminus. I think that's what we called him.
Name?
Yeah, it's his name. It took me way too long to get the actual like design of him on there, but anyway, that was done. And yeah, there we go. So these are two players, like they're interacting with it there. And obviously we can only share the one monitor, so you can only see the one person's perspective. Okay.
It's working.
All right, great. And that's our presentation.
Yeah, I really love this project actually. How much of it was coded by scratch from your team, and how much of it was like not?
It was essentially entirely coded by scratch. So we used the ncurses library, which is just a library that, like a text-based user interface, all it does is it lets you draw characters onto the screen. So like I made a function that will draw the vertical lines. How the raycaster works, it's like a series of vertical lines. So I render those in, but all of the math with the raycasting was done by Fazell. I can pass it to him. He was sort of involved with the math side of it.
Well, I mean, I didn't invent this algorithm. This algorithm existed for like decades, but I did research on it and applied it, built it from the ground up, and applied it to this, but just to make it run in the terminal. It casts rays, and the rays determine how far away the wall is, pretty much, and then draws the line. Draws a line depending on how far away the wall is. It's an abridged version of it.
I don't think I've got a question, but very impressive to get that done what you've done. So well done.
Yeah, it's actually very impressive what you've done here. I'm just very curious about like where to next. What features do you want to add in next?
So, well, as you can see, the gun's there's no shooting though. That's kind of a problem. There was obviously the time constraint of the hackathon that made it so that we couldn't get everything we wanted. Originally, the idea was supposed to be have a full-on, like a Doom style deathmatch, like classic Doom style. Obviously, that didn't happen. We got an online, like, server going on and clients connecting to it. But obviously, we can have some sort of hit scan that allows you to, shoot other players and have matches and stuff like that. Have a health that would be sent to and from the server, and that kind of thing. Maybe more maps. We had ideas for a map editor as well, but that didn't exactly pan out. We have the design for it, but just not the protocols to make it work within the game. That's all.
Yeah, I would say it's also kind of amazing how late a lot of the things actually fully got developed. Because like actually getting in the sprite, like aligning to the screens was done just late last night, and getting in the gun was done in the early hours of the morning. So like
5, 6 a.m.
yeah, we had like all the math mechanics done, but there was a lot to do, and I'm pretty happy with what we managed to get done.
Yeah, really fantastic job, guys. This one looked like a lot of fun. Just a question maybe about the multiplayer aspect of it. I know that multiplayer game networking is very hard at times. Did you just do that from scratch basically as well?
Yeah, that was also done entirely from scratch. I'll pass it on to Zell. He's in charge of that whole department. Sorry, Cardi.
So basically, I took my knowledge from CSSE 2310, and we basically made like a TCP server. And he mentioned UDP, and he was like, it's faster and less reliable. And I thought it would be similar. However, I was dead wrong. It took too long, very long, but in the end I got there. But yeah, it was basically all from scratch. I had to figure out how to get data, like small amounts of data. Like what I needed to figure out what exactly I needed to send to the client, what did I have to send as the server, and if I made that incredibly lightweight, there would be little to no latency.
All right, thank you to our last group, terminally insane. I'm sure the Linux and the large Linux users will love this game. So yeah, that's it. That's all the presentations. Can we give our presenter a round of applause? Thank you. So next, while the judges will be making their final decision on the runner prize and the best overall prize, you're free to exit this room and roam around, stretch your legs, touch some grass if there are some. But yeah, we'll be back in this room around 30 minutes. Thank you.